Hello everyone, welcome to our channel Physics for AP. Today we are going to discuss about the most important topic, that is acids, bases and salts. So most of the users asked about the acids bases chapter. So today I am going to explain about the acids, bases and salts. So from today onwards our episodes will be starting from this chapter. So in this chapter we'll be going to discuss about the physical properties of acids, bases and salts, and next we'll be discussing about the indicators. So what are indicators, what are the types of indicators? In that we'll discuss about the natural indicator and artificial indicators, and also we will discuss about the universal indicator, so which belongs to the pH scale, so where we define about the strength of the acid and strength of the base, and also the application of the pH scale. And next we'll be discussing about the chemical properties of acids, bases and salts. So in this we'll be discuss about the reaction of metals, the reaction of carbonates and hydrogen carbonates, and the neutralization reaction which is common for the acids and base. And for acids, reaction of metal oxides with the acids, and reaction of non-metal oxides with the base. And next we'll be discussing about the salt chemical properties, that is we'll discuss about the family of salts. And next we'll discuss about the chlor-alkali process, and from that we'll be discussing about the preparation of bleaching powder, baking soda and washing soda, and these applications where we use it. And we'll be discussing about the water of crystallization. So this is the overall acid, base and salt which we are going to about discuss. And today we will be discussing about the physical properties of these acids, bases and salts, and also we will be discussing about the indicators. So let's move to the physical properties. So here we have the physical properties of acids, bases and salts. So let us see what are the physical properties of acids first. So acids are the substances which are in sour in taste. So like the grapes which you eat, the grapes, the tamarind. Okay, so how they taste like? So they taste like sour. So all those substances are what we call it as acids. So the substances which are sour in taste are called as acids. And also the substance which dissociates H plus ions in water. That means they produce H plus ions when they are mixed into water. So for example, we have an acid over here. So when it dissociates in water, it decomposes. That means it displaces into H plus ion and A minus ion. So as we are having a H plus ion over here, so that means it belongs to the acids. So all the acids have the H plus ions compulsorily. So if there is no H plus ions, then that means it is not an acid. So definitely there will be the H plus ions in it. And acids conducts electricity. So as usually acids can conduct electricity, and they are mostly in liquid nature, that is in aqueous solution. So the acids react with base to form salt, which we call the neutralization reaction. So they react with bases to form the salt, and they turn the blue litmus into the red litmus. So it's an indicator which turns the litmus solution from blue to red. That means if it is turned to red, then it is said to be called as an acid. And coming to the examples, here we have H2SO4, which is called the sulfuric acid, and HCl, which is called hydrochloric acid, HNO3, which is called nitric acid, CH3COH, which is called acetic acid, and H2CO3, which is called carbonic acid, and H2SO3, sulfurous acid. So these are the some of the examples for the acids, and if you observe in all the compounds we have hydrogen here, so it is said to be called as an acid. So these are the properties of the acids. Now coming to the base. So the bases are the soapy to touch and bitter to taste. So they are soapy to touch, like how we use the soaps. The soap which we're using is a base, so as it is soapy to touch, and if you taste the soap, it is little bit bitter. So the bases which we are saying are soapy to touch and they are bitter to taste. And next one, the substances which dissociates the OH minus ions. As for acids they release H plus ions, but for bases they release OH minus ions. Like example, we have some metal hydroxide over here, MOH, metal hydroxide. So when it dissociates, it becomes metal ion, that is M plus, and OH minus ion. So if there is a OH minus ions released, so then that is said to be called as a base. And they also conduct electricity. So even the bases also conduct electricity, and they are mostly in liquids, and the most of the bases dissolve in water. So the bases which dissolve in water are called as alkaline. So they are called as alkaline when they dissolve in water. But some bases do not dissolve in water, so they don't call as alkaline. But the bases which dissolve in water, then it is said to be called as alkaline. So here the bases react with acids to form the salt, which is called the neutralization reaction. And coming to the litmus solution, they turn red litmus to blue. So they turn the red litmus solution to the blue litmus over here. Okay. Now coming for the examples here, we have NaOH, which is sodium hydroxide, KOH, potassium hydroxide, MgOH, magnesium hydroxide, AlOH thrice, which is called aluminum hydroxide, and CaOH twice, which is calcium hydroxide. So these are all the examples for the bases, and these are the properties of the bases which we have discussed now. Now next, coming to the salts. The salts, as we usually we know that they are salty in taste, so they don't have any particular any other taste. So salts are nothing but they are salty in taste. And acids and bases, they dissociates to form H plus and OH minus ions, right? But salts produces ions, that is cations and anions. Okay, that is the cations which are present in acidic nature and the anions which are present in basic nature. That is what we call acid base. When the acid and the base reacts, we get salt over here. So that acidic nature we get a cation, and basic nature we get a anion over here. Okay, so like example, if we take NaCl, so NaCl is a salt. So when we dissociate, when we come divide it, we get Na plus and Cl minus. So this is cation which is acidic in nature, and this is anion which is basic in nature over here. So the substances are ionic in nature and they produce ions. So cations are basic nature and anions are cations are acidic in nature and anions are basic in nature. And salts dissolved in water can conduct electricity, otherwise cannot. The salts dissolved in water, so salts directly cannot conduct electricity, right? So salts dissolve, when the salts are dissolved in water, then only they can conduct the electricity, otherwise they cannot. So salts, as they are in solid in nature, we know that salts, all the salts are solid in nature, so they cannot conduct electricity. But when they are dissolved in water, then it dissociates into ions and they can produce electricity over here. And salts are formed by the combination of acid and base. When an acid and base combine, we get a salt over here. And coming to the litmus over here, as there is no change, as usual purple color will be there. So the color of the litmus is purple, so no change for the litmus solution. And the examples for the salts are sodium chloride, NaCl, that is potassium chloride, KCl, MgSO4, magnesium sulfate, MgCl2, magnesium chloride, copper sulfate, sodium carbonate, and calcium carbonate. So these are the examples of the salts over here, and these are the properties of the salts. And now we will be discussing about the indicators. So the substances which show the nature whether it is an acid, a base or a salt. So the indicator is nothing but it is a substance which is prepared naturally or artificially, and it tells us the nature of the substance whether it is an acid, a base or a salt. So that is what we call as indicator. So indicator are two types, one is natural indicator, another one is artificial indicator. So let us see about the natural indicator. So natural indicators are the indicators which are prepared from the plants. So that means which are prepared naturally. So the natural indicators such as litmus solution, turmeric solution, beetroot juice, red cabbage, China rose. So we have different. So I have given only few of them which are very important. So these are the natural solutions over here, and the color of the natural solutions is litmus solution, which is in purple color, turmeric as yellow color, beetroot purple, red cabbage purple, and China rose red. Now let us see the color of the acid and base when we mix these solutions over here. So acid, when as they are in purple color, so when we mix the acid into the litmus solution, it becomes to red, and bases turns into the blue color. And turmeric solution, so there is no change over here. So in acids, so yellow, that means there is no change, but in bases it becomes deep red. Next, coming to beetroot juice, so as they are in purple color, so in acids no change, but bases it turns into yellow color. Red cabbage, so as their purple color, so when coming to the acids it turns pink or red. So pink or red, that means based upon its nature, that is what we call the strong acid and weak acid. So based upon that color changes whether it is pink or red. And coming to the base, it turns to green or yellow. Here also based upon strong acid or strong base or weak base, based upon it will turn its color green or yellow. And China rose, as it is red in color, for acids it becomes magenta color, and for base it turns into green color. So this is about the natural indicators which prepare from the plants. And next, coming for the artificial indicators. So artificial are also called as synthetic indicators. So they are prepared from the chemicals. So like example, methyl orange, methyl red, phenolphthalein. So these are the artificial solutions. And for acids, the methyl orange color is red, and for bases it turns to orange or pale yellow color, also we can call pale yellow color. And methyl red, for acids it turns red color, as you know change, but for bases it turns into yellow color. And phenolphthalein solution, for acids colorless, as the phenolphthalein solution is a colorless liquid. For acids there is no change, but for base it turns into pink color. So this is about the artificial indicators which are prepared from the chemicals here. And next, coming to the universal indicators. So the universal indicators is nothing but a solution which exhibits several colors and indicates the strength of acid or alkaline or a salt. So it exhibits several colors, like starting from red to blue, and middle we have orange, yellow, green. So based upon several colors, so it indicates the strength of an acid, an alkaline, or even salt also here. And let us see, we have a pH scale. So universal indicator is also called the pH scale, which is called the potenge, which means a German word, or also called as the power of hydrogen ions. So more the hydrogen ions, less the pH value. Okay, so more the hydrogen ions, less the pH value. Less hydrogen ions, more the pH value will be. And this was invented by Sorensen, the scientist, a German scientist. And by using the pH scale we can say the strength of an acid, whether it is a strong or weak. So the pH scale starts the value from 1 to 14. So 1 to 14, and The 7 indicates the neutral, which is the salt here, and which is in green in color. And coming from less than 7, that is 6, 5, 4, 3, 2, 1, all these are said to be called as acidic. And nearly 1, 2, 3, so is said to be called as strong acid. 5, 4, 5, 6, which are said to be called as weak acid. So it turns starting from red and orange. And coming to here above 7, that is 8, 9, 10, 11, 12, 13, 14, these are the basic in nature. And 8, 9, 10, which are weak in nature, that is weak basic. And 12, 13, 14, so these are the strong base. So it ends from blue, and in the middle we have yellow over here. So this is about the pH scale. So it starts from 1 to 14 with several colors, and with neutral starting from 7, it is a salt, and red, which is an acidic nature, and blue, which is a basic nature. So this is about the indicators, that is the natural indicators and the artificial indicators here. And coming to the universal indicators, the pH scale, we have some of the applications of the pH scale so in our daily life. So let us see the applications of pH scale in our daily life now. So the first thing is the plants and animals are very sensitive to the pH range. So all the living organisms survive only a narrow range of pH range. That means they have a certain value of pH range. So beyond that pH range, so they cannot get survive. So the acid range, so acid range are which are less than 5.6, the pH value 5.6, as 7 is in neutral, below 7 is acidic nature. So if the acid range, that is the range which are below 5.6, then they are said to be called acid range. So they make the plants and the aquatic animals to survive difficulty. Why? Because these acid rains damage the entire oxygen levels which are present in the water, so the aquatic animals cannot survive. Even the plants also cannot survive, as the transporting system gets damaged due to the acid rains. But how are these acid rains formed? So these acid rains are formed due to the pollutant gases which are released in atmosphere. So we have the pollutant gases like sulfur dioxide, nitrogen dioxide, carbon dioxide, and some other gases we have. When these gases which are releasing from the factories, when they are reacted with water molecules which are present in the atmosphere, so when they are reacted with the water molecules which are present in the atmosphere, so the sulfur dioxide reacted with the water to form H2SO3, that is sulfurous acid. So when react with nitrogen dioxide, we get HNO3, and when it react with carbon dioxide, we get H2CO3, which is called carbonic acid. So these acids, they combine into the cloud, and when they get heavier, so they fall down as an acid rains. So that is why these acid rains are mainly can be seen near to the industrial areas, that means where these polluted gases are being released. So the government has issued that near to these factories or in the industries which release these pollutant gases, they should not be there surviving near to it. So that is why these factories and the industries are being sent far away from the villages. And coming to the second point, that is the pH causes the tooth decay. So even our mouth gets tooth decay when it has a lower pH value of 5.5. So in our tooth we have a tooth enamel which is made up of calcium phosphate, and this is the hardest substance in our body. So it doesn't react with water, that means it doesn't dissolve in water, but it can be corroded when the pH value is less than 5.5. As the substance which we are eating, like candies and the sugar, chocolates, and the boiled rice or fried rice, whatever it may be, So we have some amount of the oil, that is the fatty oils, and as well as the sugar substance. So they get stuck between the teeth. So they get what we call, they get decomposed and form a bacteria, and that bacteria converts into an acid and makes the pH value of our mouth less than 5.5. And to neutralize this problem, we use a toothpaste. So the toothpaste is basic in nature. So the acid which we release, which is released from our mouth, so we neutralize it with the basic, that is the toothpaste, so that we can prevent the tooth decay. And coming to the next is the pH value of our digestive system. So our stomach produces the HCl, that is hydrochloric acid, a strong acid which digests the food without damaging the stomach. So the HCl which is released from our stomach doesn't damage our digestive system, but it makes the food to digest. But during indigestion, that means if we take more excess amount of food, or during indigestion, excess acid is released and it causes pain and irritation for us. So as it causes pain and irritation, so due to the release of more HCl, now we need to neutralize this. To neutralize this, we need a base. That base is nothing but we call antacid. So antacids are made up of milk of magnesia, that is magnesium hydroxide. Okay, so this magnesium hydroxide, or called as milk of magnesia, or also called as antacid tablets or antacid solution. So it neutralizes the acid which is present in our stomach, as it is a base. It neutralizes the acid in our stomach and gets a relief for us. So that is what the pH in our digestive system. And coming to the pH of the soil, so before doing agriculture, so the farmers usually they test the pH nature of the soil, whether it is an acidic or basic. So why? Because the previous crop which they have used, they use a more amount of manure. So due to that, the soil may become acidic or it may be basic. Now to grow a new crop, so the based upon that crop production, a good crop production, we need to test the soil and see that whether it is an acidic or basic. So when it is in acidic in nature, we need to convert into a basic by using basic components. And if it is a basic nature, we need to add some acidic components, so that it becomes neutralized and converts into a salt, and that salt is used for the production of the plants, the production of the crop. If we won't test the pH nature of the soil, obviously they may get damage of the crop production. That means we won't get more yielding over here. That is why it is better to test the pH of the soil before doing the crop production. And also the pH value in our everyday life, not only about the plants and animals for their surviving, also like we take bee stings. Bees, they get stings for us, that means to survive from themselves, and as well as wasp sting. As bee sting is acidic in nature, for that we need a base to get neutralized. And wasp sting, as it is in basic in nature, we need an acid to neutralize over here. So which is the formic acid, which is released over here. And a wasp sting is nothing but a hydroxide, metal hydroxide, which is a strong base over here. And also nettle leaves. So the nettle leaves, so they make itching. That means when the nettle leaves fall upon our hand, so we get more itching and more scratching over here. So that is due to the release of methanoic acid. So due to the release of methanoic acid, that is HCOOH, methanoic acid, due to the release of more amount that acid, so it gets more itching, and to neutralize that we need to add a base so that it can be released, like a base such as a baking soda, or we can use a toothpaste also. So even not only these, the plants and animals which have a acid and a basic nature. They use it for their survival also. So these are the importance of the pH in our daily life. That is, the plants and animals need a narrow pH range, like they need to survive from the acid range. And next, the pH range causes the tooth decay, and also the pH in our digestive system, as well as the pH of the soil. And also some of the animals and plants, they use this acid or a base to survive themselves over here. So this is about the importance of the pH in our daily life. And now what we have discussed is, we have discussed about the physical properties of acids, bases and salts, and we have discussed about the indicators, the natural, artificial and universal indicators, and we have discussed about the pH scale and the strength of acid, strength of base, that is based upon the pH scale, which is nearly to 1, we say it as strong acid, and which is nearly to the 14, we say it as strong base. And we have seen the applications of the pH scale also. So thank you for watching the video. Please subscribe the channel and click the like button if you like it, and give your valuable comment. I'll be waiting for it. Thank you everyone.